Imagine this. A company wakes up one morning to find all its customer data missing. Not stolen, just gone. Their servers didn't crash. Their data center didn't burn. Their network wasn't hacked in the traditional sense. Instead, a single misconfigured cloud bucket left open to the internet was quietly accessed, copied, wiped, and replaced with a ransom note. No alarms, no alerts, no signs of forced entry. This is the new battlefield. This is cloud security. For decades, companies protected their data by locking it inside physical servers, machines they could touch, rooms they could guard, cables they could trace. Security teams knew exactly where their data lived because they could literally walk up to it. But today, the world has moved from metal to mist, from physical servers to AWS, Azure, and Google Cloud, from locked rooms to global distributed infrastructure, from predictable perimeters to borderless environments, and with this shift comes a new reality. Cloud security is not just IT security in the cloud. It is an entirely different discipline. To understand why, we need to break down the fundamental differences, the new risks, the new responsibilities, and the new mindset required to secure modern cloud environments. In traditional security, you protect a building, a server room, a firewall boundary. In the cloud, there is no physical boundary. Your data could be in Mumbai, Singapore, Frankfurt, or Virginia, sometimes all at once. This means the old idea of protecting the network perimeter collapses. Instead, cloud security relies on identity, permissions, policies, and configuration. A hacker no longer needs to break into your building. They just need to find one misconfigured cloud resource. This is the single biggest mindset shift. In the cloud provider, AWS, Azure, GCP, secures the infrastructure. You secure everything you put on it. Think of it like renting an apartment. The building owner ensures the structure is safe, but locking your door, that's on you. Many companies misunderstand this and assume the cloud provider handles everything. This misunderstanding has caused thousands of breaches. In traditional environments, you configure hardware. In the cloud, you configure APIs. Every resource, servers, networks, storage, databases, is created, modified, and destroyed through APIs. This means a single API call can expose your entire database. A single script can misconfigure hundreds of resources. A single stolen access key can give attackers full control. Cloud security is therefore automation security. Cloud is elastic and ephemeral. Servers appear and disappear automatically. IP addresses change. Containers spin up and down. Workloads move across regions. This makes traditional monitoring tools useless. Cloud security requires continuous, real-time visibility. Cloud has infinite scale, including infinite risk. In the cloud, you can deploy 1,000 servers in minutes, but you can also misconfigure 1,000 servers in minutes. Speed is a double-edged sword. Security must match the speed of DevOps. One of the most famous cloud breaches in history happened to Capital One. What happened? A misconfigured AWS WAF web application firewall allowed an attacker to access metadata credentials. Using those credentials, the attacker accessed S3 buckets and downloaded sensitive data. Why it happened? Misconfigured IAM roles, over-permissive access, lack of monitoring, and failure to follow least privilege. What it proves: cloud breaches rarely happen because AWS or Azure failed. They happen because customers misconfigure the cloud. This case became a global lesson. Cloud security is configuration security. Cloud security is like air travel security. Think of traditional security like driving your own car. You control everything: speed, route, maintenance. Cloud security is like flying in a commercial airplane. The airline handles the aircraft, the engines, the runway, the air traffic control, and the safety systems. but you still handle your luggage, your passport, your seatbelt, your personal belongings, and your behavior on the plane. If you leave your passport on a bench, the airline isn't responsible. Similarly, if you leave your cloud storage bucket open, AWS isn't responsible. This analogy helps people understand the shared responsibility model instantly. Before diving deeper, let's understand the three major players: AWS, Amazon Web Services, the oldest and largest cloud provider, known for flexibility, massive service catalog, and global reach. Microsoft Azure, deeply integrated with enterprise systems, Active Directory, and Windows environments. Azure is favored by large corporations. Google Cloud Platform, GCP, known for AI, machine learning, Kubernetes, and high-performance computing. Each cloud provider has its own security tools, identity systems, network models, logging frameworks, and encryption mechanisms. But the core principles of cloud security remain the same. Cloud security requires a new way of thinking. Here are the mindset changes every learner and company must adopt. In the cloud, who you are matters more than where you are. IAM, Identity and Access Management, becomes the most critical security layer. Everything must be encrypted. Data at rest, data in transit, data in use. Cloud providers make encryption easy, but misconfigurations make breaches easier. When systems are not configured properly, even strong encryption cannot prevent unauthorized access or data leaks, making attention to settings and implementation critical for security. Zero trust is mandatory. Never trust, always verify, continuously monitor. Zero trust is not a tool, it's a philosophy that demands that every request be authenticated, authorized, and continuously validated, regardless of where it originates from, for maximum security. Manual security cannot keep up with cloud speed. Automation is the only way to enforce consistency. Cloud operations move too fast for manual processes, so automated controls and responses are essential to ensure that security policies are applied reliably across environments. You cannot secure what you cannot see. Cloud environments require continuous monitoring, real-time alerts, and automated compliance checks. Visibility into all resources and activities is essential in order to detect threats and ensure compliance. If cloud security were a human body, IAM would be the heart. Every request, every login, every API call, every resource creation, every permission check, everything flows through IAM, making it the central component for secure access and resource management. In traditional IT, identity was simple. You had a username, a password, and maybe a badge to enter the building. But in the cloud, identity becomes a complex ecosystem involving users, groups, roles, policies, service accounts, machine identities, temporary credentials, federated identities, API keys, and tokens. This complexity is why 80% of cloud breaches involve IAM misconfigurations. Let's break it down in a way that's simple, visual, and unforgettable. To understand how errors in identity and access lead to major vulnerabilities in cloud security. IAM analogy. The airport security system. Imagine IAM as the entire security system of an international airport. Users are passengers. Groups are categories like business class, economy, crew. Roles are special access passes like pilot, engineer, security officer. Policies are the rules that define what each pass allows. Temporary credentials are boarding passes that expire after the flight. MFA is the passport check. Federated identity is when your passport from one country is accepted in another. If someone gets the wrong pass, or worse, a pass with too many privileges, they can walk into the cockpit. That's exactly what happens in cloud breaches, where attackers exploit overly permissive or misconfigured access to gain control. AWS IAM. AWS uses IAM users, IAM roles, IAM policies, JSON-based, STS, temporary credentials, access keys, MFA, and organizations SCPs, service control policies. AWS IAM is extremely powerful, but also extremely easy to misconfigure. Azure Active Directory, AAD. Azure integrates deeply with enterprise identity systems. It uses users, groups, service principals, managed identities, RBAC, role-based access control, and conditional access policies. Azure's IAM is built around identity governance. GCP IAM. GCP uses members, roles, service accounts, IAM policies, and workload identity federation. GCP is known for its granular permissions and least privilege defaults, focusing on security by default. Common IAM mistakes that cause cloud breaches. Over-permissive roles. Developers often assign administrator access in AWS, owner in Azure, project editor in GCP. These roles give full control over everything. Attackers love this. Long-lived access keys are often stored in GitHub, Jenkins, Slack, email, or on local laptops. These keys become golden tickets for attackers who gain access, as they can use them to compromise cloud environments. Without multi-factor authentication, MFA, if a password is stolen, an attacker can gain full access to cloud accounts. This turns a single stolen password into a complete security compromise. Developers, testers, and production admins often share the same privileges in cloud environments. This lack of role separation is a violation of basic security principles and increases risk. Service accounts assigned to machines often have more privileges than human users. Attackers target these accounts to escalate privileges and gain widespread access. Traditional networks rely on firewalls, VLANs, subnets, and physical segmentation. Cloud networks, in contrast, are software-defined, fully virtual, and controlled by policies rather than physical hardware. AWS networking consists of VPCs, virtual private clouds, subnets, public and private, security groups, stateful firewalls, NACLs, stateless firewalls, route tables, internet gateways, NAT gateways, VPC peering, and transit gateway. AWS is extremely flexible but demands careful planning. Azure networking uses VNets, subnets, NSGs, network security groups, ASGs, application security groups, Azure Firewall, private endpoints, and ExpressRoute. Azure emphasizes robust enterprise connectivity and secure segmentation. Google Cloud Platform Networking includes VPCs, subnets, firewall rules, Cloud Router, Cloud NAT, shared VPC, and VPC service controls. GCP is unique for its global VPCs, allowing networks to span worldwide regions easily. Attack Path 1. A developer uploads AWS access keys to GitHub by accident. An attacker discovers these with automated scanners. They can now access S3, spin up EC2 instances, exfiltrate data, and delete logs. This is a common type of cloud breach. Attack Path 2. A storage bucket is mistakenly set to public. Attackers scan for and download customer data, internal documents, source code, and backups. This mistake has affected thousands of companies. Attack Path 3. A database is placed in a public subnet with port 3306 open to the internet. Attackers brute force the database and extract all its contents, leading to major data loss. Attack Path 4. An attacker compromises a low-privilege account, finds an IAM role with IAM pass role or STS assume role, and escalates to admin privileges. This is extremely common in AWS environments. Attack Path 5. Attackers target serverless functions like AWS Lambda or Azure Function that have hard-coded secrets, over-permissive roles, or no input validation. They use these weaknesses to breach internal systems. Encryption remains one of the strongest defenses for cloud security. safeguarding sensitive data against unauthorized access, even if attackers breach other defenses. Cloud providers offer encryption at rest, encryption in transit, encryption in use, confidential computing, customer-managed keys, provider-managed keys, and HSMs, hardware security modules. Let's break this down. Encryption at rest, data stored in S3, Azure Blob, GCP cloud storage, databases, and disks is encrypted automatically. But the real question is, who controls the keys? Encryption in transit. TLS is mandatory for all cloud communications, but misconfigurations can still expose data. Encryption in use, confidential computing. This is the future of cloud security. Data remains encrypted even while being processed. This protects against insider threats, cloud provider access, and memory scraping attacks. Azure, AWS, and GCP all offer confidential computing options. All cloud providers offer KMS, AWS KMS, Azure Key Vault, GCP Cloud KMS. These services manage encryption keys, rotation, access control, auditing, and HSM-backed security, but misconfiguring KMS can expose encrypted data. If there is one villain in the cloud security world, it is not hackers, it is not malware, it is not nation-state attackers, it is misconfiguration. Cloud misconfigurations are responsible for over 65% of all cloud breaches worldwide. Why? Because the cloud gives you enormous power, but with that power comes enormous responsibility. Let's break down the most dangerous misconfigurations that companies make every day. Public storage buckets, S3, Blob, GCS. This is the classic mistake. A developer creates a storage bucket. They want to test something quickly. They set the bucket to public so they can access it easily. They forget to change it back. Attackers scan the internet 24/7 for open buckets. They don't need to hack anything. They simply download whatever is inside. This is exposed: passport scans, medical records, customer databases, source code, internal documents, financial reports. A single misconfigured bucket can destroy a company's reputation overnight. Open security groups' firewall rules. Cloud firewalls are powerful, but they are also easy to misconfigure. Common mistakes include allowing SSH 22 from anywhere, allowing RDP 3389 from anywhere, allowing database ports 3306, 5432, 1433 publicly, allowing entire subnets unrestricted access. Attackers constantly scan cloud IP ranges for open ports. Once they find one, they brute force it. Over-permissive IAM policies. Developers often take shortcuts. Let me just give admin access for now. I'll fix permissions later. It's only for testing. But later never comes. These policies allow attackers to escalate privileges instantly. Developers accidentally commit AWS access keys, Azure Service Principal secrets, GCP service account keys, database passwords, and API tokens to code repositories. Attackers use automated bots to scan GitHub for leaked secrets within seconds of upload. Serverless functions often run with full access to S3, full access to databases, full access to IAM, and full access to logs. If a serverless function is compromised, attackers gain access to everything. Many companies forget to enable CloudTrail on AWS, activity logs on Azure, or audit logs on GCP. Without these logs, you cannot detect or investigate breaches. Each cloud provider offers powerful built-in security tools, but most companies don't use them properly or at all. Let's break them down. AWS IAM Access Analyzer detects overly permissive roles and policies, helping you minimize excessive cloud permissions. AWS GuardDuty offers threat detection powered by machine learning. It identifies compromised keys, unusual API calls, suspicious network traffic, and malware activity. AWS Security Hub provides a central dashboard for all security findings, allowing teams to quickly assess and prioritize issues. AWS Config tracks configuration changes and compliance in your cloud environment, making it easier to maintain secure settings. AWS CloudTrail logs every API call in your account, providing essential history for security investigations and audits. AWS Macie uses artificial intelligence to detect sensitive data stored in S3 buckets, such as personally identifiable information, PII, or financial data. AWS Inspector scans EC2 instances and containers for vulnerabilities, helping teams address security weaknesses before attackers exploit them. Microsoft Defender for Cloud provides unified threat protection across Azure, AWS, and GCP, offering broad security coverage across multiple cloud platforms. Azure AD Identity Protection detects risky sign-ins and compromised accounts, helping prevent unauthorized access. Azure Sentinel provides a cloud-native SEIM for threat detection and response, enabling security teams to investigate and mitigate incidents efficiently. Azure Key Vault offers secure storage for secrets and cryptographic keys, ensuring only authorized applications and users can access them. Azure Policy enforces compliance across resources, making it easier to ensure that all cloud assets adhere to security standards and company policies. Azure Monitor collects logs, metrics, and alerts from applications and infrastructure, giving companies greater visibility into their environment. Google Cloud Security Command Center (SCC) provides a centralized security dashboard for monitoring threats and vulnerabilities across your cloud environment. CloudArmor offers DDoS protection and a web application firewall (WAF), shielding cloud resources from large-scale network attacks. Cloud Audit Logs track all administrative and data access events in GCP, giving teams an accurate record of who accessed or changed cloud resources. Binary authorization ensures only trusted container images are deployed to your cloud environment, protecting against unverified code. VPC service controls protect data from unauthorized access by enforcing security boundaries around cloud resources. Cloud DLP, Data Loss Prevention, detects sensitive data across cloud resources, such as credit card numbers or personal information, and helps reduce exposure risks. In the cloud, logs are everything. Without logs, you are blind. Let's break down the essential logs for each cloud provider. CloudTrail logs every API call. This is the first thing investigators check after a breach. CloudWatch Logs collects logs from applications, Lambda functions, and systems, offering broad visibility into AWS activities and issues. VPC Flow Logs track network traffic inside AWS, making it possible to monitor allowed and denied connections for security and troubleshooting. S3 access logs show who accessed your storage, what actions they performed, and when they occurred, providing valuable forensics in security investigations. Azure Activity Logs track all administrative actions, giving insight into who made changes and when. Azure Monitor Logs collect logs from applications and infrastructure, enabling analysis and detection of security or operational issues. NSG Flow Logs track network traffic in Azure, supporting security monitoring and troubleshooting of connectivity issues. 4. Azure AD Sign-In Logs shows authentication attempts. GCP Logging. 1. Cloud Audit Logs tracks admin and data access events. 2. VPC Flow Logs tracks network traffic. 3. Cloud Logging, centralized log storage. 4. Cloud Monitoring, metrics, alerts, dashboards. Section 16. Threat detection in the cloud. Threat detection in the cloud is different from traditional environments because workloads are dynamic, IP addresses change, resources scale automatically. Attackers use cloud-native techniques. Cloud threat detection relies on machine learning, behavioral analytics, identity-based alerts, API monitoring, network anomaly detection, automated remediation. Let's explore real-world cloud attack patterns. Attack pattern 1, credential theft. Attackers steal access keys, tokens, service account keys. They use them to impersonate legitimate users. Attack pattern 2, privilege escalation. Attackers look for misconfigured IAM roles, pass role permissions, over-permissive policies. They escalate to admin. Attack pattern 3, lateral movement. Attackers move between EC2 instances, containers, serverless functions, databases. They search for secrets and credentials. Attack pattern 4, data exfiltration. Attackers use S3 sync, cloud storage copy, Azure blob download, encrypted tunnels, steganography. They quietly extract data. Attack pattern 5, crypto mining attacks. Attackers deploy EC2 instances, Azure VMs, GCP compute engine to mine cryptocurrency using your cloud bill. This is extremely common. Section 17, Real-World Cloud Breach Case Studies. Case Study 1, Uber, AWS keys leaked. An attacker found AWS keys in a GitHub repo. They accessed Uber's cloud environment and stole data. Case Study 2, Facebook, public S3 buckets. Millions of user records were exposed due to misconfigured S3 buckets. Case Study 3, Tesla, crypto mining attack. Attackers exploited a Kubernetes console with no password. They deployed crypto mining containers. Case Study 4, Accenture, open cloud storage. Sensitive data was exposed due to unsecured cloud storage. Case Study 5, Verizon, misconfigured S3 bucket. Millions of customer records were leaked. These cases prove one thing: cloud breaches are preventable. They happen because of human mistakes. Part 4, DevSecOps, CI/CD security, governance, compliance, and incident response. Section 18, DevSecOps, security shifting left. Cloud security is no longer something that happens at the end of development. It must be integrated from the very beginning, inside the code, inside the pipeline, inside the workflow. This philosophy is called DevSecOps. What is DevSecOps? DevSecOps means embedding security into development, testing, deployment, operations. Instead of security being a gatekeeper, it becomes a collaborator. Analogy: security as a seatbelt, not a speed breaker. Think of DevSecOps like a car seatbelt. A seatbelt doesn't slow you down. It lets you drive faster, safely. Similarly, DevSecOps doesn't block development. It enables faster, safer releases. Section 19, Securing the CI/CD pipeline. The CI/CD pipeline is the bloodstream of cloud applications. If attackers compromise the pipeline, they can inject malicious code directly into production. Let's break down the major risks and how to secure them. Risk 1. Compromised source code repositories. Attackers target GitHub, GitLab, Bitbucket, Azure DevOps. If they gain access, they can steal source code, inject backdoors, modify configurations, steal secret solution. Enforce MFA. Use branch protection rules. Enable code signing. Scan for secrets. Use SAST, static application security testing. Risk 2. Insecure build servers. CI servers like Jenkins, GitHub Actions, and Azure pipelines often run with high privileges. If compromised, attackers can modify build artifacts, steal environment variables, deploy malicious containers. Solution: use ephemeral build agents. Restrict permissions. Rotate credentials. Use isolated runners. Scan build environments. Risk 3. Secrets and pipelines. Developers often store API keys, cloud credentials, database passwords inside pipeline variables. Solution: use AWS Secrets Manager, Azure Key Vault, GCP Secret Manager, HashiCorp Vault. Never store secrets in plain text. Risk 4. Untrusted dependencies. Modern applications rely on thousands of open-source libraries. Attackers exploit dependency confusion, typo squatting, malicious packages. Solution: use SCA, Software Composition Analysis. Pin dependency versions. Use private package registries. Enable automated vulnerability scanning. Section 20. Cloud Security Frameworks. Cloud security is not guesswork. There are established frameworks that guide organizations. Let's explore the most important ones. 1. CIS benchmarks. The Center for Internet Security provides benchmarks for AWS, Azure, GCP. These benchmarks define secure configurations for cloud resources. 2. NIST Cybersecurity Framework, CSF. NIST CSF is built around identify, protect, detect, respond, recover. It is widely used in government and enterprise environments. 3. ISO 27001, a global standard for information security management. Cloud providers offer ISO-certified services. 4. SOC2 focuses on security, availability, confidentiality, processing integrity, privacy, essential for SaaS companies. 5. PCI DSS, required for companies handling credit card data. Cloud environments must be configured to meet PCI requirements. 6. HIPAA. For healthcare data in the United States, cloud providers offer HIPAA-eligible services. Section 21. Cloud Governance. Controlling chaos. Cloud environments grow fast. Without governance, they become unmanageable. Cloud governance ensures consistency, compliance, cost control, security, standardization. Let's break down the pillars of cloud governance. Pillar 1. Identity governance ensures least privilege, role separation, access reviews, automated provisioning, and MFA enforcement. These controls help assign the minimum necessary permissions, keep sensitive duties separated, check access regularly, automate account setup, and require multiple authentication factors. Pillar 2. Resource governance ensures naming conventions, tagging standards, region restrictions, resource quotas, and cost allocation. Proper governance helps maintain order in resource management, tracks spending, assigns resources to the right teams, and follows organizational rules. Pillar 3. Policy enforcement uses tools like AWS Organizations SCPs, Azure Policy, and GCP Organization Policies to enforce rules across the entire cloud environment. For example, no storage bucket can be created without encryption. These policies ensure consistent security and compliance. Pillar 4. Compliance. Governance ensures cloud resources meet standards like CIS, NIST, ISO, SOC 2, PCI, and HIPAA. Compliance is a continuous process, not a one-time effort, requiring ongoing monitoring and updating of security controls. Section 22. Incident response in the cloud. Incident response in the cloud is different from traditional environments because servers are ephemeral, logs are distributed, resources scale automatically, and attackers use cloud-native techniques. Let's break down the cloud incident response lifecycle. Step 1. Detection is triggered by GuardDuty alerts, Azure Sentinel alerts, GCP SCC findings, anomalous IAM activity, and suspicious network traffic. Step 2. Containment includes actions like revoking access keys, disabling compromised accounts, isolating VMs, blocking IPs, and restricting IAM roles. The cloud allows rapid containment if you know what you're doing. Step 3. Investigation. Investigators analyze CloudTrail logs, activity logs, VPC flow logs, application logs, and IAM role usage. They look at API call patterns and reconstruct the attacker's path in the environment. Step 4. Eradication involves removing malware, fixing misconfigurations, rotating secrets, patching vulnerabilities, and updating IAM policies to eliminate threats and restore security in the cloud environment. Step 5. Recovery. Teams restore clean workloads, secure configurations, updated policies, and hardened environments to ensure the cloud infrastructure is safe and robust after an incident. Step 6. Lessons learned. Organizations document what went wrong, what worked, what needs improvement, and how to prevent recurrence. This is the most important step in incident response. Section 23. Advanced Cloud Security Best Practices. Let's go deeper into the techniques used by mature cloud security teams. 1. Zero Trust Architecture. Assume nothing is trusted, verify everything, and continuously monitor. Zero Trust includes identity verification, device verification, network segmentation, least privilege, and continuous authentication. 2. Infrastructure as Code Security. Tools like Terraform, CloudFormation, ARM templates, and Pulumi allow you to define cloud infrastructure in code. But IAC can also introduce misconfigurations. Use Checkov, TerraScan, TFSec, and Kix to scan IAC's vulnerabilities. 3. Container security. Containers must be secured at the build stage, registry, runtime, and orchestration layer. Tools include AWS ECR scanning, Azure Container Registry Scanning, GCP Container Analysis, Aqua Security, Twistlock, and Trivi. 4. Kubernetes security. Kubernetes is powerful but complex. Security includes RBAC, network policies, pod security standards, image signing, secrets encryption, and admission controllers to ensure a secure cluster. Cloud providers offer data loss prevention (DLP) tools to detect sensitive data such as PII, PHI, financial data, credentials, and sensitive documents. These tools prevent accidental exposure and help organizations safeguard their most valuable information from breaches or mismanagement. Security teams use automation to fix issues instantly. For example, if a storage bucket becomes public, automation immediately makes it private within seconds. This proactive response prevents data leaks and enhances the overall security of cloud environments by reducing response time to incidents. Cloud security is evolving faster than any other field in cybersecurity. The threats targeting cloud infrastructure are becoming smarter. Environments are more complex, and the attack surface expands every day. Staying ahead requires understanding where the future of cloud security is heading. Artificial intelligence is transforming cloud security. Cloud providers now use AI to detect unusual API calls, identify compromised credentials, analyze billions of logs in seconds, predict misconfigurations before they happen, flag suspicious user behavior, and detect malware inside containers and serverless functions. Imagine a security system that learns your environment, understands what normal behavior looks like, and instantly alerts you when something feels off. This is not science fiction. It is happening right now, changing how we protect cloud resources. The next evolution is autonomous, self-healing cloud environments. Imagine a public S3 bucket automatically becoming private, a compromised key automatically revoked, a suspicious VM quickly isolated, or a misconfigured firewall rule instantly corrected. Cloud security will reduce human error, the leading cause of breaches. Today, encryption protects data at rest and in transit. But the future is encryption in use. This means data stays encrypted even while being processed. Cloud providers cannot see your data, attackers cannot extract data from memory, and insider threats become powerless. This is the future of privacy and secure computation. Zero Trust will become the default architecture for enterprises, governments, cloud-native startups, and critical infrastructure. Identity will act as the new passport. Every request is verified, every action is monitored, and every device must be authenticated to maintain tight security. Companies are increasingly using AWS for compute, Azure for enterprise integration, and GCP for AI and analytics. This creates complex multi-cloud environments. The future will bring unified security platforms that monitor all clouds, enforce policies, detect threats across providers, and provide a single pane of glass. Quantum computing will break traditional encryption. Cloud providers are already preparing for post-quantum cryptography, quantum-safe key exchange, and quantum-resistant algorithms. The cloud will be the first environment to adopt quantum-safe security. Cloud security is one of the highest-paying, fastest-growing careers in the world. Here's a clear, structured roadmap for learners. Stage 1. Foundations. Beginner. Learn networking basics, Linux fundamentals, identity and access concepts, virtualization, and basic scripting, Python, Bash. Stage 2. Cloud fundamentals. Choose one cloud provider first, like AWS Cloud Practitioner, Azure Fundamentals, or GCP Associate Cloud Engineer. Learn compute, storage, networking, IAM, and monitoring. Stage 3. Cloud security basics. Learn the shared responsibility model, encryption, IAM best practices, logging and monitoring, and cloud-native security tools. Stage 4. Hands-on security skills. Practice securing S3 buckets, hardening IAM roles, configuring VPC firewalls, enabling CloudTrail or activity logs, and setting up GuardDuty, Defender, or SCC. Stage 5. Advanced cloud security. Learn Zero Trust, DevSecOps, CI/CD security, Kubernetes security, serverless security, and infrastructure as code security. Stage 6. Certifications, optional but valuable. Highly respected certifications include AWS Security Specialty, Azure Security Engineer, Google Professional Cloud Security Engineer, CCSP, Cloud Security Professional, and CISSP for senior roles. Stage 7. Real-world experience. Build projects like secure multi-tier architecture, automated remediation scripts, IAC security pipelines, Kubernetes hardened clusters, and cloud SEIM dashboards. Stage 8. Senior and leadership roles. Roles include Cloud Security Engineer, Cloud Security Architect, DevSecOps Engineer, Cloud Governance Lead, Cloud Security Consultant, and CISO, long-term path. Cloud security is not just a job, it is a future-proof career. Let's bring everything together in a way that hits the viewer emotionally and intellectually. Recap: we began with a simple truth. The world has moved from metal to mist, from physical servers to invisible global infrastructure, from locked rooms to borderless digital universes. And with that shift came a new battlefield, one where identity is the new perimeter, misconfigurations are the new vulnerabilities, APIs are the new attack surface, automation is the new defense, zero trust is the new philosophy, and AI is the new guardian. We explored how AWS, Azure, and GCP secure the modern world. We saw how companies fall, not because the cloud is weak, but because humans make mistakes. We learned how attackers exploit public buckets, stolen keys, over-permissive roles, misconfigured firewalls, and vulnerable pipelines. We studied real-world breaches that shook the world. We explored the tools, frameworks, and best practices that protect millions of users every day. We looked into the future, a future where AI defends the cloud and security becomes autonomous. Data stays encrypted even while running. Multi-cloud becomes the norm. Quantum computing reshapes encryption. And finally, we mapped out a clear, achievable career path for anyone who wants to become a cloud security expert. Now it's your turn. If you've watched this far, you're not just curious, you're committed. You're part of the next generation of cybersecurity professionals who will secure the digital world. So here's what you do next. Keep learning, keep practicing, keep experimenting, keep breaking things safely, keep building secure systems, keep pushing your limits. Because the cloud is not slowing down. The threats are not slowing down. And the world needs people like you, people who understand how to protect the future. If you want more deep, cinematic, real-world cybersecurity content, subscribe to Knowitrix. Turn on notifications. Share this video with someone who needs it. Comment what topic you want next. This is Knowitrix. This is your journey, and this is just the beginning.